Hello and welcome to this video on Statistics for Psychology, Chapter 9, looking at the t-distribution. And the t-distribution is a statistic that we use when we are not able to determine the standard deviation of the population. So when we're not, essentially, when we're not using standardized tests. When we use standardized tests and we have the mean and standard deviation of the population based on the standardization of that particular test, all we need to do is compare our score to those standard scores using the z-test, and we're all set. So what I'm going to do with this, in this chapter, what we're setting out to do is, when do we use a z-test and when do we use a t-test? And then we're going to conduct a one-sample t-test in SPSS. So without further ado, let me first, in order for the compare to know that we're traveling here from the z-test over to the t-test, they're actually the exact same test. But we have to make some assumptions and adjustments for the fact that we don't have all the information on the population. So let's first review the z-test and how we actually use the z-test, the thing we've already been doing. So as in everything, we have a question about the population. In the class, we've been talking about different populations, and we come up with a question, some sort of factor or some sort of intervention. We want to know if that makes a difference with people like the people that we're looking at, people in the population. So we have that question, and we're wondering how that impacts the population. Now, because we're using standardized tests, remember we're talking about z-tests, we know the mean, standard deviation, and the distribution of sample means of everybody that has already taken that standardized test. So therefore, we have this nice standard bell-shaped curve. This is the distribution of sample means that we can use to determine whether our sample, because of our intervention, is different. So we take a sample from this population, we set it aside, we introduce our treatment conditions, and then we look at the means, whatever we're measuring, whether it's learning outcomes or grades on a test or scores on a standardized test or something like that. And then we're left with making a decision based on that value that we have just calculated. Is that mean close to the middle? Likely to have gotten by chance, therefore it's not significant, our particular intervention didn't work, or it's way on the outside. And here we have is if the sample mean is somewhere in the middle, then we reject the experimental hypothesis. If it's somewhere over to the end, and it's pretty unlikely that you would get this by chance, we would assume that it's because of the intervention that it moved the score all the way over there, and we would reject the null hypothesis. Now this line of thinking of you have a question, create the hypotheses, you collect your data, you look at how that data compares to standardized scores, and then you either accept or reject the null hypothesis. That's pretty much what we're doing in t-tests, except in t-tests, we don't have the goodness of all that information. So here we go. Let's take a look at t-tests. So we're still in the position of asking questions about the population, but we're not using standardized tests. We're just using the data that we have available to us. We're using our own testing mechanisms. A lot of what happens in schools, if I was going to do evaluations on my tests that I conduct in my classes to see how valid and reliable they are, they're not standardized. They're just the tests that I use. Now, because of this, because of these estimations that we need to make, you can tell why standardized tests are really nice to use, because they give us that ability to compare very effectively with good statistics to other people who have taken that test. That's the nice thing about standardized tests. Creating a standardized test is a whole it's a huge process involving lots and lots and lots of work. But most of the time we're going to be dealing with experiments and studies where we're not as knowledgeable about all of these areas. We don't know necessarily the mean of the population. We don't know the standard deviation, and we don't know that distribution of sample means. So this thing can't be used. That's not what we're going to be using. Yet, here we are. We decide we're going to sample anyway. We take a sample, put our treatment conditions, measure our variable, the dependent variable. We would manipulate our independent variable, and it would produce a change in our dependent variable. And then we have to talk about a different equation. And I introduce here the equations. Don't get too intimidated by this. I'm going to try and... We have our Z formula here, and we have the T formula, and they're basically exactly the same thing. Here we have the Z-score is basically you take the score you got, you subtract from it the mean of the population and divide it by the variance. So in these equations, we're really only talking about those two factors that we looked at the beginning of the semester, which was central tendency and variance. So we're looking at the difference between your score and the average score, and how variable is this? And then we're getting a determination of how different you are from people who have taken this test. That's using a standardized test. Now we have to modify that a little bit when we're looking at t-tests, and what we're looking at is the x with the line over it is the average value, your average means, minus the same mean for the population. I'm going to tell you how we come to that. And then a value for variance that takes into consideration sample size. So it is essentially the same formula. You're taking that x value, which is your mean, you're subtracting it from the population mean and over the variance within your sample. Your sample variance is an estimate of the population variance. And the formula that says S, standard deviation, over the square root of n takes into consideration the fact that the number, the n, how many people you have. If you have a really large sample, then your sample probably better represents the population. If you have a really small sample and that number is really small, then it's not a very good, there's tendency to more variance. So mathematically, it's keeping that in mind. So what we have here, first let me deal with this, the thing that looks like a U. This part right here, you guess, and that's what it is. It is a guess as to what would be the population mean on this particular assessment. So if I was going to, let's say the treatment conditions, I was looking at my class, and here we are doing a video, and I want to see if the video impacts your success in doing the assignments. That's my intervention. So the average population mean would come from the same assessment as it's been done in the past. I'd look at all the records that I have, and I would make a determination as to what is the average performance of people who have taken this before. And in addition to this, I could pre-test everybody. Now that pre-test, post-test thing is a form of this, and we're actually going to talk about that in the next class, the next chapter. But nonetheless, we make a guess as to what the average would be. It's a little sketchy, isn't it? So we sort of like look at our assessments and we look at what we've done before and we say, okay, I think the average person would get a 50 on this. Now the example in the book, actually, it tells you a statistic that you can actually, it's very accurate. The ability for someone to guess the suit in cards is 1 in 4, 25%. So let's say, for example, my test was a 10-question multiple choice test with 4 answers on each one. I could either get a more accurate example of what people have done before by looking at my records, but it could also say, well, if everybody guessed, the likelihood of getting right answers is about 25% for each one of those questions. So a 25 would be the answer of somebody who's just guessing. I could actually use that 25 score, 25% right, people just guessing, as my population mean to see if my intervention made it better than guessing. And so back to the formula, we have that population mean being guesstimated, and then in addition to that, the standard deviation of the sample is used, and it's in a fraction with the square root of the number of samples that you have, the n, the number of people that you sampled from. So that's the difference between the z-test and the t-test. So in the t-test, we used the standard deviation of the sample is used, that was that S, to calculate the standard error, that's the name of that S, over the square root of n, and large samples closely resemble the population. So we are going to take a little journey in here. Now that right there is how you could do it by hand, but we're going to be using SPSS, and there's an activity where what we are going to do is you look at the data on page 192 in the textbook. It's the Stop and Think exercise 9.6. You follow the steps that are outlined in page 191 in SPSS. I want you to play around a little bit with the number value that we use as the population mean. It gives it to you in there. It gives you a value of 100, but maybe we can look at 120 and 20 and 92, anything there, and kind of like talk about the logic. Now this is not a graded part. This is a time in class when I would have you sit down, do this, and then we're going to review it. So the next slide is going to be pause the video. I want you to go and do that assignment. I want you to go to page 192 in SPSS. I want you to create the table. I want you to calculate, you following the steps on page 191, I want to calculate the one sample t-test. So pause the video, and I'll see you in just a little bit. Now we're back rather quickly here. I'm going to bring up the statistical package here. Let's take a look at this. Here I have SPSS. This is probably microscopic when you're looking at it here. So I have the table. I have entered all the data here. And this is the stuff from page 192. And the steps for this is I go to Analyze, and I go to Compare Means. Now it's comparing the mean that I got to a hypothetical mean when we're using a one sample t-test. There's still a comparison going on. So I just go over to one sample t-test. And I only have one variable. Actually, if you open this up, it would look like this. I've named it score, so it's over here, and that's the test variable that I want to do. So there's the score. And right here, this test value, that's where you put the population mean. That mu, that thing that looks like a little U. You put that in there, and I put 100, just like the instructions in the textbook, and I press OK. And it produces for me a one sample t-test. Now the T value is 2.496. The degrees of freedom is 17. We know that the N is 18, so degrees of freedom is N minus 1. The two-tailed significance is 0.023, which is less than 0.05. So, in fact, this is a significant difference between these and what a theoretical standardized test here. So this one sample right here did produce, if the population usually scores a 100, that's what I've determined here, then this group scored significantly higher. Now that number, 2.496, is a number that you can look up in the T tables within your textbook. Now those tables there, they are organized. You look up the T's, you have the T score in your head, but you look up the degrees of freedom. So you look up 17, and then depending on whether you're doing a one-tailed or a two-tailed test, you would look to see where your number is, where it's in between, and it tells you whether or not you've met the 0.05 or 0.01 levels of significance, just using in the table. But SPSS gave you exactly what the p-value is, 0.023, which is better than 0.05. And I think as I talked to you before in the class, sometimes we go ahead and we report out the exact figure rather than saying, yes, the T, degrees of freedom, 17. That's how you write it out. T, little t, degrees of freedom, 17, equals 2.496. Probability P less than 0.05. You can do that. Or we could say P equals 0.023. Either way is fine. So now that you know how to do that, we switch over to the course book. And let's look at the assignments. I'm trying to get this to actually come up here a full page, but anyway, we have a discussion where I want you to consider when you would actually use a one sample t-test when you don't know those standard scores. That's the discussion. You could look that up on the web. When do I use a one sample t-test? Get some examples there, kind of get your head wrapped around that. Chapter 9 quiz consists of some multiple choice questions on stuff from the textbook. And there are two labs. One is hypothesis testing with a single sample, basically writing out those H1 and HO, experimental and null hypotheses with a single sample. And then conducting a one sample t-test in SPSS. And that brings us to the end of Chapter 9. So I hope been able to talk about moving from z-tests into t-tests when we don't know, which is a lot of the time, unless you're using standardized scores, we really don't know the population mean. So just easing into that area, we're going to spend a lot of time in t-tests, just various kinds of t-tests, different groupings, and then we're going to look at paired and matched samples, or in Chapter 10, it's just another kind of t-test, and it's that same area inside of SPSS that we're going to be playing around in. So hop to it, get into these things. When we meet for class, since we've already talked about this stuff, we'll be going over the labs when we meet the next time. So stay tuned for Chapter 10.